Welcome. This is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium, which took place in Kuala Lumpur, Malaysia. This conference is made possible through the support of the PKI Consortium Post-Quantum Cryptography Working Group and our sponsors SSL.com, Entrust, Keyfactor, HID, and Crypto4A. And with exceptional organizational support from SSL.com, Keyfactor, Logius, POS Digicert, Baker Tilly, MSC Trustgate, and Digitoris. Join the discussion. Join the PKI Consortium. Go to pkic.org/join.
So this next session is PKI agility and the difference to cryptographic agility, lessons from the past and the present. And I'm pleased to introduce Michael Osborne. He's an IBM Distinguished Engineer and the Global CTO for IBM Quantum Safe. Welcome, Michael.
So I work for IBM Research, and IBM Research not only makes quantum computers, but also makes quantum safe cryptography. This is something that we started developing 10 years ago, and I'm fortunate enough to have some very clever cryptographers in my team. We were very successful in the algorithms that we developed, getting them into NIST. I've been doing this now 25 years. So I've seen quite a lot of transitions, getting towards the end of my career. So I'm very grateful to have this opportunity to pass on some of the learnings, which I hope this presentation does. And I think the key for me is there are a couple of things which cause a lot of confusion. One of them is agility, the term agility. The other one is the term hybrid. It means very different things to very different people. And actually, when it comes to cryptographic agility, changing algorithms, it's a very, very different topic than actually changing trust. And what we're talking about, PKI, is one of the enablers for distributed trust. And I'm going to go through some examples of learnings that we have made. There are many definitions of agility. At the end of the day, businesses, if they are going to implement something, an easy way to change cryptography, there has to be a benefit. It can't just be changing from one cryptographic algorithm to another. There's this aspect, it needs to make financial sense. So how we look at agility is very much, yes, we need to be able to do it, but there's many other areas where organizations use cryptography that costs money, whether it's export control or things like this. So we have this aspect that it has to be financially interesting for organizations, or it's very, very difficult to get a business case to actually apply agility. Now, agility, there are very many different touch points. So everyone, I think, recognizes the algorithmic side, but the operational side of managing cryptography is very different. It's very much tied to automation and architecture. This is also something that's not very widely discussed. But for us, cryptographic agility is a subset of organizational agility. If you have the right architecture, modern container platforms, it's a lot easier to add on things like cryptographic agility. Governance. So one of the issues we have is that governance is not always the most agile thing when it comes to cryptography. We're lucky enough to have governance. How often do people update their cryptographic policies? Not so often, because it's very difficult. But perhaps the most important is the ecosystem. At the end of the day, unless you control every single thing that you do, you're only going to be as agile as your vendors, because those are the people that will need to provide you with the things that you need in order to implement the new cryptography and become quantum safe. So if we look at this on kind of like a life cycle of cryptography, this helps us to explain why different people have different perspectives on agility. Look at the design and the standardization phase. So this is the last 7 years at NIST. It's a long time. It took 7 years to actually look at a series of algorithms, figure out which are the ones that make most sense and trade-offs. Agility there is being able to what you don't want are algorithms which are very difficult to configure in different security strengths. If you move to implementation and assurance, the agility there is being able to add new crypto algorithms. So this is very much like vendors, hardware security module manufacturers. So it's very much about adding algorithm. But when it comes to the other phases, integration and deployment, this is where things start to get interesting, and I'll show you some examples of why this transition between one phase of this life cycle and the next comes with problems. Management and operation. So what we also see is that the cryptographic know-how is very high on the left-hand side, people who design algorithms, but it really tails off the further you go on this life cycle. We have a management and operation phase. So this is very much around people who need to keep crypto up to date, are responsible for compliance, things like this. And the final phase is this transition in retirement. We've not been very good at this, okay? So in terms of knowing what we need to do to transition securely. And what we see is that things tend to move from design and standardization phase this way, okay? People throw things over the fence. They do things which are sensible for their industry, for their part of the life cycle, but actually what we need to do is start from the transition and retirement phase. These are the requirements that nobody on the left-hand side sees. So we often design products and services which and guidance and procedures which do not help organizations when it comes to what they have to do to actually retire cryptography. That's the information that they need to collect, the operational policies that they need, et cetera, et cetera. So we have this framework. I think I'm not going to go through all of the details on this. I think the slides will be available. There are points pertinent to each of these life cycle stages. Each one of these life cycle stages has a different perspective on what agility is. What does that mean? So one of the complications is if you talk to a vendor of cryptographic, a PKI system, for example, they will talk about agility being, we can easily support these new algorithms. If you go over now to a vendor who now has to implement PKI technology, this is all about the governance, I'll move to this stage, the configuration management, making sure that when they change something, this works. So it's a very different perspective on agility. There are many, many more things that are many more complicated than what a PKI vendor will see. One example here, move to one example of these mismatches between phases. So there are mismatches between every phase. So cryptographers develop algorithms that are with very specific requirements, okay? This might be the security normally. So actually it was very good from NIST, for example, not just to take the most secure algorithms, because actually NIST was fairly aware that the most secure algorithms are actually the most difficult to use. They're very large, very complicated, so we need the right trade-offs. And each stage of this life cycle has different trade-offs. So this is an example of a mismatch between a provider. Maybe this is an example of PKCS11, which is a common international interface for dealing with cryptographic modules. You see, very easy for a vendor to add the new algorithms to a HSM or a cryptographic module. But if you look how you have to program PKCS11, it's pretty complicated because the vendor, what they want is for that product to be used in as many situations as possible, okay? So you can have fairly high cryptographic agility with a cryptographic module, but now you come over to the integration and deployment phase. So somebody who needs to program an interface to that hardware security module. That program is usually in an application, okay? Meaning how the HSM has been configured for that application is somehow programmed into is programmed into the application. Meaning if you need to change anything there, you need to change the application. And this is something that we really want to get away from, touching applications, because touching applications is a very, very difficult thing. I think we heard today that some applications, some devices have been 60 years in the field. We have mainframes that are still running very sensitive programs 50 years old. There's nobody alive that actually built those systems. So every time we have to touch an application, especially when they're large and complicated, it's not so good. Every time we need to reconfigure something, some people may have seen the challenges with reconfigurations at one of the hyperscalers this week. Organizations do not like to touch configuration. So configuration management is very sensitive. This is usually when things go wrong. So I've heard a lot of talks recently about looking at like infrastructure, for example. when it comes to operational agility, there are many other areas where we use cryptography that may be not so well known, but are very important. Time being one of them. So I don't hear this discussed in PKI, but what happens if somebody changes the time on the system? You can mess around with revocation dates, you can mess around with ordering on blockchains. There's a whole lot of things you can do with messing around in time. Time, trusted time, network time protocol is like one example. Trusted data is the same. So if you look at what we call black box cryptography in products and services, trusted data like sanctions lists and all things like these are all data, pieces of data that we trust that are signed. They get sent over TLS. We'll not worry about TLS, but nobody sees what's happening. Nobody really protocols what's going over these TLS interfaces because it's difficult. But the danger or the ability of a quantum adversary to manipulate trusted external entities is very, very, very large. I'm going to go for an example on trusted time. So it's trusted time, trusted data, trusted location. These are things which are usually external, which are not usually under the control of your organization. This is what I mean when we talk about the distributed aspect. If you have control over everything, you're in a good place. If you don't, then you really have to start being very aware of what you trust and where that trust comes from and how it's protected. This is just a sort of an example of threat to financial system if you cannot trust time anymore. The legal issues, cross-border fragmentation, all of these things. How many people have looked at the trust model behind the network time protocol or one of the other time protocols? Probably not many people. This is a challenge with a number of standards which are not front and center for becoming quantum safe. They're not quantum safe, and there's nobody really looking at them. So if you look at, this is something the IETF does, NTPv4. If you look at some of the cryptography in these standards, how many people know this cryptography? Huh? This was like deprecated an awful long time ago. And it's just every time we go to a client and then start digging down into business processes, we find all sorts of standards and things that are not being looked at from a quantum security perspective. So dealing with, and the challenge that we have generally in industry is if the path is like this, that a vendor asks, a supplier to do something, they might know the standards. They might go to the standards organization and start working on it. Take a time before they can implement the new standard. All of these things add a lot of latency to when something will be available to correct this issue. Some of the feedback that we've provided to the European Union is, no, things like standards organizations, that needs to be handled separately. Standards organizations need to provide inventories of standards that they have and where public key cryptography is used. You can't wait for suppliers to do that. It will just take too long. Many things like this. PKI agility. So it's actually pretty easy to issue new certificates. Pretty easy. Once you understand the algorithms and can make them safe, it's really too easy to issue certificates. But the problem is asymmetric. The problem is verifying certificates, not issuing certificates. Essentially, you are dependent on, you need to know where certificates will be verified. That's easy if it's in your own organization, but it's not easy if it's external. So all of the operating systems or all of where the cryptography which is used to verify a certificate needs to be able to verify the algorithms. It's a very asymmetric issue. There's a lot of additional things like time. There's like, do you trust how is the trust group protected? Certificate transparency. So there's a whole set of trust services around the verification of certificates, which is usually, which adds a whole level of complexity in terms of how and when you can migrate. So again, very easy to update certificate issuance, very difficult to make the verification of certificates safe. And we come to one of the other challenging terms, hybrid, because there's a lot of discussions, I think, around hybrid. I don't like the term hybrid because it's very confusing. and a lot of the guidance is actually not very clear on this topic. So if you talk to cryptographers, merging things together at the cryptographic level in a hybrid way is very interesting. Okay, if you talk to operations people, managing composite certificates is very, very, very difficult, which is why we like to talk about dual root schemes. There are things you do for strength in depth. There are things you do to manage migration. And it's a bit, what do we want? Do we want to manage PQC migration? Do we want to sort of make things more secure? I mean, they're very different goals at the end of the day. There's a whole set of pros and cons for each. If I would summarize the message here, that composite certificates where things are merged together very low are incredibly complex when it comes to migration. They're incredibly complex in terms of the dependencies on everything that needs to verify those. In terms of then migrating at some point away from hybrid to pure quantum safe or whatever, or dual, makes things more complicated. In the end, what we see is complexity is the things that brings enterprises the most problems. Not the underlying cryptography, it's complexity. I just wanted to, well, there's been some talk about, we know the new algorithms are larger, that they have larger public keys and things than the old algorithms. There's a very new paper from a colleague. What we see is a lot of PQC performance measurements are done on the client. They're not really done on the server side. So what's the impact of these new algorithms on server performance? Fact of the matter is, these new algorithms, we need different methods. We need to do things like rejection sampling. We need to make sure that when we generate or sign a certificate, that we choose the right things. This is the old world, essentially, where everything was pretty much the same from a performance perspective. Now we see that a lot of the, with the new algorithms, MLDSA, actually the performance is not bad for most things, but it deteriorates as due to this effect of rejection sampling. And actually there are some very long tails. What does that mean? Sorry for the complexity of the slides. That the impact on server farms, or let's say where, not on the client side, but on the server side, which probably impacts a lot of enterprises, can be significant, depending on which certificates you are involved in, essentially in the signature, what you're testing. So 2 times, 10 times, 20 times, depending on how you configure your server-side connections. Very new, so it's not just the size. The impact is essentially, you may need to redesign and re-architect how you do your server-side TLS endpoints, for example. So there is an impact, a definite impact on the server side. 5 minutes. This is a case study. I won't go into detail. Point of this case study is that if you have everything under your control, goodness, if you depend on other people and other software, not so good. So this was 20 years ago when we were moving from RSA to ECC. Actually, we were combining the two, hybrid. Most complex security use case you can imagine. We were delayed a year because one of the platforms that we needed didn't support SHA-2, essentially. So let's just go on here. There are things you can do. So given that I've tried to introduce that agility is a different things in different phases, there are different things that you need to look at in these different phases, essentially. So for example, supply chain governance, bills of materials, you know, we're very big on bills of materials. Configuration automation. If you don't have configuration automation, you are not going to be agile in your enterprises. These are things like Terraform and Ansible. Architecture and automation. If you're using container platforms, it's very easy to automate them. If you're using very old legacy systems, it's very difficult. So there's a whole series of things you can do. And I think what we've seen is that everybody says there's a lot of the like internet connections today use PQC. You can test this on your own phone. So if you look at this barcode on your phone, you'll see if your phone is supporting quantum safe. Point here is that it's not, there are mechanisms you can use, proxies and approaches, that if your phone or your platform does not support quantum safe out of the box, there are mechanisms you can do to buy time until they do, things such as proxies. So just a nice kind of like example of, you can test for yourself whether your phone is a red or a green, and there's something you can do about it. And I think with that, I'll wrap up the thought. I know it's been very, lots of different points, essentially, but all of these impact agility, and these are all kind of like some of the new learnings that we have. And I think the previous slide is probably the important one. There are things you can do at each stage of the cryptographic life cycle to manage and mitigate challenges around agility.
Wonderful. Thank you, Michael. Appreciate that. So I will turn it to the room and online. If anybody has any questions, we'll be happy to take some. Sure. Wonderful. Thank you.
Thank you for the presentation. Just want to clarify on resiliency.
Resiliency.
Yeah, crypto agility, does it a requirement for resiliency for an organization? If it is, then it's very, very critical to be part of the governance. Thank you.
I am a very big fan of resiliency. So in many countries, we're moving from cybersecurity to cyber resiliency. And it's very important, because if you go to a piece of critical infrastructure and you talk about harvest and decrypt, they will not know what's the issue, because it's not relevant to them. So it's very important to be able to talk to organizations with the threat mapped in the resiliency, confidentiality, integrity, availability, such that they really understand in their context what the issue is. Now, I'm a big fan of the resiliency dimension and the need for agility in this, because if something goes wrong, you need to be able to change quickly. So it's all about how quickly you can change to something new, and that's a key aspect of agility, of resiliency.
That's the way that we can
Yes.
agility to the board, and also
That's part of resiliency, 100%. And Jaime mentioned the DORA regulation, which is all about resiliency, and why we think that is something that should be very much aligned with the quantum safe journey.
Great, thank you.
Wonderful. Thank you. Another question back there?
Thank you so much for the information. Yesterday, we learned in the workshops that we're not talking about just one key or one certificate. There's hundreds and there's thousands. So how does that translate in crypto agility? Is it so much more complicated to implement?
So what do you need to understand when it comes to hundreds and thousands of certificates? You need a good certificate management system. You need to know where those certificates, for example, are validated. So it's part of we call it observability, the things that you need to know, not just the certificates you issue, but where they're verified, as a kind of like a prerequisite for understanding how and when, what you have to change, and when your suppliers will be ready. So it's under the umbrella of observability, I would put this.
Thank you.
Great. Any last question? All right. I think we're great. Thank you so much, Michael. Appreciate it.